Great, yeah. So this will be about vertical architectures for scaling your large-scale enterprise applications. And I want to get started not with this grumpy gardener here, but with this picture. It's a similar picture, but it's a bit different. What do you see here? There's no tooling, yeah, no tooling. They are neighbors and they have a conversation, a good conversation, I guess. So this guy here is smiling and everything seems to be nice. And one reason why they are good neighbors might be, and this is not that obvious, those fences here. Perhaps you know the saying, good fences make good neighbors. And this is also true for software development. If you have a huge application that needs to grow over time, that is implemented by several people or even several teams, then you also need good fences. You need so-called verticals. The verticals are the grounds, and the spaces between those verticals are the fences. And usually each vertical has several features that are correlating with each other. Those features are quite clear to each other. Often they know about each other. However, between those verticals, we try to have minimal dependencies. A vertical should know as little as possible about other verticals because we want to evolve the application here without breaking something there. Another important aspect here is that usually you try to align your team structure with your verticals. There is the so-called Conway's law. It's meanwhile several decades old. Back then, at the end of the 60s, Conway, an US-American computer scientist, made this observation. They called it law, but it's more of an observation. And the observation is that your team structure always mirrors your architecture. Or to be more precise, the other way around, the architecture mirrors your team size. So by looking at your architecture, you can tell something about your team structure. And I know this sounds quite theoretical, but a very practical way to explain it is if you tell 3 teams to implement one compiler, you get a compiler that is using 3 phases to compile your source code. Because obviously somehow those teams need to share tasks. They need to split the tasks. And usually a team member is talking more often to the members of their own team compared to members of other teams. And this also means we can influence our architecture by structuring the teams accordingly. This is more or less what Conway's law is telling us, or at least what the consequences and the learnings of Conway's law are. So at the end of the day, we want to have verticals, we want to have features within verticals that correlate with each other, and we want to have loosely coupling, or at least low coupling, between those verticals. And we want to align with our team structure. At the end of the day, this also helps us to stop this cascade here, where you break something here and also break something over there. We really want to avoid this. Most of the times, your changes should be local. This sounds quite nice and it sounds somehow logical. However, it comes with a lot of further questions. One question here is, how large should a vertical be? When is it too tiny? When is it too large? How to find good verticals? How to implement them? How to enforce rules? How to make sure that not each and every vertical is directly talking with each and every other vertical? And how to analyze your implementation? And those are the questions I want to answer today. Before we start, let me introduce myself. I'm Manfred. I am a trainer and consultant for Angular, and I'm focusing on Angular in the enterprise. In this role, I'm visiting a lot of companies. I'm helping them with consulting, with workshops, also with reviews. And besides this, I'm also quite connected to the Angular community. I live in Austria. I do a lot of stuff in Germany, and I'm always happy to work together with people around the globe. Meanwhile, we are quite present in whole Europe. We have several customers here in Poland, but also in the Netherlands, Belgium, Spain, and so on. Okay, so let's get started with the first question. How large should a vertical be? And there is no definitive answer to this question. However, there are two forces. One force is defining the minimum size, and another size is defining the maximum size of a vertical. And ideally, you are somewhere between those two forces. So if we look to the one side, the minimum size, then I would say a vertical should be huge enough to fit correlating features, because we want to have all the changes locally to one vertical. We don't want to have a situation where we need to change 5 verticals just to update one feature. This would be not the idea of all of this, because the idea is to have local changes, to concentrate on one thing, and to make a good job in this very tiny aspect. So correlating features should fit one vertical. And the force for the maximum size is the team size. A vertical should not be larger than what a team can achieve. Ideally, we have just one team and not several teams working on the vertical, because we don't want to have that much interaction. It is somehow counterproductive if we have to talk to 3 other teams before implementing a new feature. This was the first question about the size. The second question is not that easy to answer. It's about how to identify good verticals. There are several answers to this. But one answer I really love is this here. It's about domain-driven design. Domain-driven design, which is quite an old thing, it has been around for 20 years now, tells us to align our software with business domains, with areas from the real world out there. You know, the real world is where the pizza boy comes from. That means we look out into the real world and we try to mirror the areas of this real world in our software. This idea is also nothing but new. I think the whole object orientation is about this basic idea, but domain-driven design goes far beyond that. I've told you before, it has been around for more than 20 years. However, it's still a thing. Perhaps it's even more a thing nowadays than back then. This book here, that was the starting point of all of this, is still a bestseller on Amazon. And I think this is nothing a lot of people achieve. To write a book now about software development, that is still a bestseller in 20 years. So normally this is not the case. When I think about my Angular book, then I exactly know every 3 years I can take the book and throw it away and rewrite it, because everything is changing. By the way, there is also a vivid community, and there are also new things introduced into domain-driven design from time to time. There are conferences and so on. So if we look at domain-driven design, then we see at least 2 traditional disciplines. The one discipline is strategic design, and the other one is tactical design. When we talk about architecture, we talk mainly about strategic design, because strategic design gives you several patterns for decomposing a huge team into several parts. And you could tell or call those parts verticals, verticals that don't know much about each other, which is our goal, isn't it? Tactical design is more a bit about design patterns and practices. It's about stuff like going with entity classes, going with aggregates, going with factories, going with repositories. This is somehow common knowledge, meanwhile, and this does not really affect our architecture. That's why most of the times when I'm talking about architecture, I'm referring to the strategic design part of domain-driven design. So the big question is now, what is strategic design telling us? How can we apply strategic design to decompose a system into tinier parts, into verticals? Well, one basic answer is not to write a huge system that is capable of everything. For instance, if you have a system that is controlling your flight tickets, the temperature of your coffee, and the nuclear power plant in the neighborhood, perhaps it does a bit too much. You really try to have tinier parts that are specialized into one aspect. So instead of writing a flight system in my example, you would go with a booking part, a check-in part, and so on. And you call those parts subdomains. They mirror, as mentioned before, areas from the real world. And then you implement them somehow into your application. How you implement them is up to you. There are several strategies. You could go with folders per subdomain. You could go with several NPM packages per subdomain or libraries in your NX monorepo. You could even go with applications of their own. And this is fun now, because if each subdomain becomes an application of its own, we speak about micro frontends. This really shows how all of this is nicely fitting together. A micro frontend is nothing else than a subdomain who was put into an own application. So identifying areas in the real world is one part of finding good verticals. Another part of finding good verticals is looking at business processes. And here I'm really sorry, because we all thought we are technicians and we don't need to deal with business processes. But truth is, if you really want to identify good verticals, you have to. You have to look at the business processes. You have to know what's going on there in the domains you want to support with software. And when it comes to those processes, you can watch out for three different things. One thing is the vocabulary. If you are using the same vocabulary in different process steps, then this might be an indicator that those process steps belong to one subdomain and hence to one vertical. So in this case, we have, for instance, luggage. We have luggage here, and we are using it in check-in luggage and pick-up luggage. And what's more important, we are using it in the same sense. We are referring to exactly the same if we use the word luggage here and there. This is important, because I'm quite sure you're also using the term luggage here when booking a flight. But here you mean something different with luggage. Here the luggage is just an option you have to pay for, the option to bring one or two suitcases. Here we are talking about the real physical luggage that is checked in and hopefully picked up afterwards. So this is one indicator, same vocabulary and the same meaning. Another indicator, and this is a bit more abstract, but also a bit more helpful, is the so-called pivotal event. A pivotal event happens every time you are relieved. So think about what you are doing when booking a flight. You are really stressed out because no one understands airlines. We all know prices are going up on a regular basis. So we are really stressed out. We need to book this flight. We need to finally find time to book this flight to get a good price. But if we have booked a flight, we are relieved because we know, okay, nothing can happen. We have our ticket, it's fine. And then we have this so-called pivotal event. And after this event, it goes on a perhaps different place, perhaps at a different time, perhaps even with different people if you book for someone else. It goes on when you arrive at the airport. And one more time, you are stressed out. You need to be in time, you need to check in, you need to go through the metal detector frame and so on. But when you have done all of this, then you are relieved once again. You know, nothing much can happen anymore. I'm at the right gate. I just need to enter the plane at the right moment. So I think this really shows that such a pivotal event is some point in time where you do a check on your task list. Or to put it in another way, if your life was an action movie, then the pivotal event would be a scene cut. Something happened, a lot of bombs and shootings, and we are done, scene cut. We are going on with the next scene when we arrive at the airport. Well, in my case, my life is not that much of an action movie. It's more of one of those French movies, you know them, with a lot of dialogues. But anyway, also they have a lot of scene cuts. So that means if we look to the pivotal events, this here would very likely be a domain. And this is overlapping. That's why I told you before, those heuristics just give you indicators for what could be a good subdomain and for what could be a good vertical. And here I'm really doing this with purpose. I want to show you that not every time those different indicators need to point into the same direction. There is another heuristic, namely roles. If you look to the roles involved there, perhaps even to divisions those roles are part of, then you see that the check-in agent and the boarding agent is the same person. That's why you should be nice to them when checking in, you see them again. And when we go with this aspect, grouping everything according to roles, then this is another candidate for a domain slice. And one more time, I really made this up. We don't have those overlapping situations all the times, but I really made this up to show you those indicators are helpful, but they are just indicators, and perhaps they are pointing into different directions. Nevertheless, they can be helpful. And perhaps you are saying now, boy, this looks complicated. And yes, it's not a strict science. However, there is a good message. To cite the philosopher Michael Jackson, you are not alone. You have Alberto Brandolini, who invented something that's called event storming. Who has done event storming so far? Let me know. Oh, some of you, that's really nice. So the basic idea of event storming is to bring people together. People from the business side, people from the technical side, architects, developers. You bring them together, you lock them up in a room like this one here, and you need to have a lot of white walls, or at least walls. And then you begin modeling your business process with post-its. And the most important post-it here is the orange one, because the orange post-it shows you events that happens during the, let's call it user journey, during the business process. And then there are other post-its with other colors, like tasks or like entities, aggregates, or roles involved here or there. But the main aspect here is the event, and that's why it's called event storming. So you try to model everything, your process on a wall with post-its, and if you think, well, someone stick this post-it on the wrong location, you start a discussion. And this allows you to bring all the knowledge together from the business side and from the technical side. That's the first aspect. When you have your business processes, then you draw the lines. You can do it with a board marker, or sometimes you just need a stripe to just define borders between the process steps. And one more time, if you think the border is on the wrong location, you start a discussion. And so one more time, you bring together the knowledge of different people. And at the end of this, you have a good first domain slicing. You have good first domain boundaries. You know where it makes sense to slice your whole system into parts. By the way, two additional fancy terms from domain-driven design before we look into another discipline. One fancy term here is the so-called bounded context, and another fancy term is the so-called ubiquitous language. Let me explain. The thing when going with domain-driven design is that you don't try to model the whole world. Usually you only model one domain at once, here booking or boarding. And that's why we have flights 2 times. You might say now, well, this is not try. This violates the try principle. Don't repeat yourself. This is code duplication. But hopefully it's not. Very often it's not code duplication because we have a different perspective to our entities, to our terms from within different domains. A flight from the booking perspective is something completely different than a flight from the boarding perspective. When it comes to booking, you need a lot of data because you want to sell a ticket. You need to have a lot of data and upgrade options and price options. And if you give me 100 more bucks, you can fly first class and so on. You don't need all this stuff here in boarding. When it comes to boarding, it's just about knowing who is allowed to enter which plane. So perhaps it's just an ID and a tiny amount of properties. And this is why we really try to model each and every domain separately. From the domain-driven design perspective, this gives you code that perfectly mirrors the respective area of the real world. We don't want to have generic code that covers all the possible cases. No, we want to have code that is really a mirror of this or that area of the real world, that really fits best so that people can concentrate on this area. And as a byproduct, this is really funny, as a byproduct for the software architecture, this leads to decoupled domains and hence to decoupled verticals, because not everything is cross-connected here. Let me give you a nice metaphor. Think about a map. Usually you have a map for car roads, roads for cars, or a map showing you train connections or underground connections, or perhaps a map showing you the sewers if you work for your community, or it shows you the water pipes in the ground or the electricity pipes. But usually you don't have a map showing all of this stuff together. This would be quite confusing. This would cause cognitive overload, and it would not be helpful. It would just be too much information at once. This is the goal of domain-driven design here. So usually you model your verticals, your subdomains separately. It's not code duplication in most cases. And you have this thought border around your subdomains. And you call this thought border the so-called bounded context. This bounded context is where within the model makes sense. Outside of this bounded context, the model does not make any sense because we have different perspective to the same aspects. And inside there, we are using the so-called ubiquitous language, which is the language of your users, of the domain experts. So we don't invent terms when it's not necessary. Sometimes it's necessary because sometimes there is no good term for an aspect. But even when we do this together with domain experts. So if the domain experts call this a flight, you also call it a flight and not an air-driven transport opportunity, which would be quite generic perhaps, but it's not in the sense of DDD. So this is one aspect of identifying good verticals. It's not easy because it's not a strict science. We just have indicators and we can talk to other people, which is never a bad thing. Finally, there is a completely different perspective to the same topic. And at first glance, it has nothing to do with verticals. But if we dig into it, we find out it is really just the second side of the same coin. It's team topologies. It's a relatively young development. I think it became popular shortly before the pandemic in 2019. And it shows you 4 fundamental team topologies, which is just a structure of a team. How to define a team and what is the responsibility of this team. And also it shows how to interact between those teams. So this here sums everything up quite nicely. Here you see those 4 different team topologies. And you also see here, I've added it, the flow. Usually you want to enable flow. You want to enable your people to produce business value as easily as possible. It should not be a burden for them to produce something that is of value for your customers. So we want to have some flow there, no showstoppers, no impediments, no situations where we have to wait for 3 weeks for other teams before we can go on. And the most important team topology for this flow is the so-called stream-aligned team. It's a team having everything they need to implement business value in a given area. Those stream-aligned teams are supported by enabling teams. They teach them with regards to some special areas like, let's say, CI/CD, if this is a topic in your company, or perhaps stuff like database optimization, UX, or accessibility performance. But the goal is that eventually the stream-aligned team has all this knowledge, and that's why the enabling team is not taking on those tasks. They are helping them to learn how to deal with such complicated special tasks. Sometimes we have an own team for a complicated subsystem. For instance, if you have something that is very complex, a compiler. I have some customers that have their own compilers for writing code for adopting and standard software to different needs. Or perhaps you have to do some calculations in there, financial mathematics calculations. This could be put in a complicated subsystem. They are not producing value by themselves. However, they're producing something that is that complex that a stream-aligned team cannot take care of it. Another example here is a team doing all those calculations for payroll accountancy. You know, payroll accountancy is really a science. There are a lot of changing laws and you have to align with them. Otherwise, you end up with 1 feet in prison. This could also be such a specialist team. And then we have the platform teams implementing technical stuff that is picked up by the stream-aligned teams. Technical stuff like your own authentication library. A lot of big companies have this, or your own design system. This is nothing the stream-aligned team should concentrate on. The shell just use it. So this is the idea of team topologies. And one big thing in there, and if you read the book, you read this term on a regular basis, is cognitive load. It's all about reducing the cognitive load of the different teams so that they can really concentrate on one aspect to provide business value for this or that area. And why this looks really different to domain-driven design, it's really somehow the same. Because also in domain-driven design, when defining subdomains, we are reducing cognitive load so that we can concentrate on one aspect. But even more, we need to slice the system into parts those teams are responsible for. And those parts are our verticals. They can be subdomains. And funnily, even though they call those things fracture lines, parts where you slice your system into tinier parts for stream-aligned teams, they also say the most common fracture line is the business domain. This is where they are referencing to domain-driven design, something that has been around for several years. This is the most common one to say. So when possible, look out for business domains. However, they also say sometimes it's not possible to fully align with business domains because there are so many forces. And so they are pointing out further fracture planes like regulatory compliances. Think about this payroll example. You have some experts that really know how to calculate all the taxes you need to pay for your employees to not end up in prison. Or change cadence. If you have one area that is not changing a lot and another area that is changing on a regular basis because you have to align with laws and otherwise you have an issue, then also this could be an indicator that you have a team for those rapidly changing stuff. And there are other things like team location, risk, performance isolation, technology, or even user personas. Perhaps a last example here. If you write an e-procurement system, then you have several business domains, but beyond that, you have 2 or 3 groups of people interacting with each other. You have the employee, you need to get a new pencil, and you need the manager that says, no, you don't get a new pencil because you already got one last week, that's too expensive. And then you have the purchase department that is putting all the metadata in there from their vendors so that the manager knows, oh, we have this pencil and we have this more affordable pencil. So perhaps this is also good enough for you. And yeah, in this case, perhaps this is a good fracture plane to slice everything according to those main roles. Okay, this was a lot of theory, but now let's come to practice. Now let's talk about how to put all of this into our source code. And for this, we have several options. When you have identified your verticals, you could implement them as folders, as libraries, NPM packages, or applications, which is where Micro Frontends come in. In general, what we do a lot, and here I'm referencing to the smart people from the NX team, we are subdividing our system not only into business domains, but also into layers. For instance, we have a feature layer with smart components. We have a UI layer with dump components. The big difference here is you need smart components to drive your use cases, but smart components are not reusable. They are tinkered for one use case, buying a pencil or doing the taxes. And that's why they are not reusable. However, to get in some reusability, you have to go with dump components. You have a data layer communicating with the backend and providing your data model. And you have an utility layer for general purpose utility stuff like, authentication or internationalization, calculating dates, and so on. Stuff you wished you would get for free from a library, but sometimes you don't get exactly what you need from a library. And this here brings a lot of order into your system. Everyone exactly knows where to put something and where to find something. And it allows us to define access restrictions, like we are only allowed to navigate top-down or from the left to the right. I think the later one is more important because it's more in the sense of verticals and domain-driven design, where we only navigate from left to right, which means booking can only talk to booking stuff and to shared stuff. And boarding can only talk to boarding stuff and to shared stuff. Booking and boarding are not allowed to interact with each other. We want to have low coupling between them. Also, layering is nice because it prevents for cycles. It prevents that everything is intermingled with each other. Here, a feature can only talk to UI, data, utility. Data can only talk to utility. So this decouples everything nicely. How to implement this? Well, we use NX a lot. Who is using NX? Okay, some of you. Cool. And NX gives us those module boundaries. We can define that this aspect is not allowed to communicate with that aspect of the application. And it gives us incremental CI/CD. That means we don't need to build everything every time. And we don't need to retest everything every time and relint it. NX knows what has been changed. And then only the changed stuff will be used, will be rebuilt, relinted, retested. And to speed it further up, we have the so-called build cache, but also we can do everything in parallel in the NX cloud. So this is quite nice. However, and I always have a however, if you go with traditional NX, all those cells here become libraries of their own. And for some people, this is completely okay. Some people told us, well, this is quite a lot of libraries. However, this is how NX is working, because NX mainly operates on a per library basis, and so you end up with, I have not counted, with a huge amount of libraries where you can define access restrictions where incremental CI/CD happens. To compensate for this a bit, usually we try to switch out this aspect of NX by a community library. It's the Sheriff. The DS Sheriff, it's an open source project, and it does the same on a per folder basis. Also, it works with and without NX. So if you say NX is too much for us, then perhaps Sheriff is of use anyway. So if we look at our stack here, we still use NX, but the modularization is done on a per folder level with Sheriff. It tells us, well, code in this folder is not allowed to access code in that folder. And to analyze everything afterwards, we will look into this in a minute, we have another tool, it's called the detective. You know, the Sheriff and the detective work together. In Germany, there was this Friday night soap, or it was a crime soap with a detective, and I think the other one was a lawyer. So I always have those two people in mind. They work together. The one guy had the brains and the other guy had the fists, and together they achieved a lot. Well, perhaps it's the same here with detective and sheriff. I will look into it in some minutes. And now it's demo time. And then I have an announcement for you, so stay tuned. We have something we are showcasing for the very, very first time today. And funnily, it nicely connects to the first talk about performance and barrels. So this was really a good pointer into the right direction. Thanks for this. But before I announce a brand new thing, let's have a look to our example here. In this example, we have an NX workspace. It has a flights application. Besides this, it also has a miles application and a library shared between flights and miles. However, and this is the point for now, if we look into the flights application, we see several domains. Seems like the flights application is pretty huge. We subdivided it into several domains. We have a check-in domain and a luggage domain and ticketing and shared. And if we look in there, we see within, let's say, luggage, we have a data layer, we have a feature layer, we have a UI layer. Also in ticketing, we have data and also two features here. So what you see here is nothing else than a translation of the matrix we have discussed before into a folder structure. So we have slices, verticals, domains, and we have layers. Let's look here. Slices, verticals, domains, and layers, feature UI data. Feature UI data. Okay, cool. So let's look in there. For instance, let's look into ticketing. There we have a booking feature. And in there, of course, we can access stuff from other modules, from other, in our case, those are modules, but technically they are just folders protected by the sheriff. However, if we try to grab over to a part of the application we are not allowed to use, we are getting those squiggles. We are getting a hit on our fingers. It tells us, hey, Manfred, what do you think? What are you doing? You are in the domain ticketing, in the feature layer. You are not allowed to grab over to the domain luggage. Don't grab into other domains. It's like going into different buildings and taking something out of the fridge. It's not considered polite in most countries, I know. So don't do this here. You don't have clearance. Or to emphasize it, it's really forbidden. And to further emphasize it, it's verboten. You know, I've learned this from my English friends. They are really using the German term verboten to say strictly forbidden. So it seems like, German language has some qualities when it comes to strictness. Okay, cool. So we don't have any broken windows anymore. Even more, if we go to the console and run the linter, we get the same error message. And that means you can automatically check for your architecture during the commit with Husky of your source code or during your CI/CD process. And this really prevents you from getting broken windows. That's really cool. It forces people into the right direction. To get all of this, you just need Sheriff. It's basically a linting rule. And then, as you can assume, you are defining tags for different folders, like a tag ticketing or feature or luggage. And then you define restrictions for those tags. So now let's go one step further. Let's analyze our architecture. Because perhaps even though we have Sheriff, there are some glitches in there. And if you use NX, you know the NX graph, which is quite nice. And I really love it. The thing is, NX works as NX all the times on the level of libraries. And here we just have one library and two applications. We cannot drill into flights with NX. And to make this possible, we have another project, which is called the Detective. And this is kind of nice. At first glance, the detective gives us the same information. It says, hey, you have ticketing, you have luggage, you have check-in, and all of them are using the shared area. And here perhaps we get suspicious because we see, hey, why is ticketing directly accessing luggage? This is not allowed. Well, this is because we broke the rules before in my live demonstration. We are not allowed to grab over to our other domain. That's why we got those quiggles. So let's get rid of this. Let's save it. And now let's restart the detective. Yeah, looks a bit better. This now looks what we have seen in our NX dependency graph. However, we can now drill down. We can say, let's go down for check-in, let's go down for luggage, let's go down for ticketing. Let's group everything by folders. And then we see, yeah, well, it seems like we have several domains. And each domain is more or less isolated. They don't talk to each other anymore. However, obviously, the modules within the domains talk to each other. This makes sense because that's why they are part of the same module. Here we also see that feature booking is using a lot of stuff from the shared area. You can tell this by looking at the thickness of this line. And when we click here, we see, yeah, here we have 7 connections. And here where the line is a bit thinner, we just have 1 connection. So this is what the structure of our application tells us, which is quite nice. I don't assume that you display everything at once. I assume that you play around a bit with it and activate and deactivate certain parts to get several impressions about the healthiness of your architecture. However, we can go deeper here. We can talk about change coupling. It looks like the same. It really looks like the same as before. However, it's a completely different kind of coupling, because change coupling tells us that perhaps this guy and that guy was changed together with one commit. That means here we are looking into your Git history. And if we find out that quite often this guy and that guy have been changed together, this is an indicator for a hidden coupling. That means even though there is no real coupling in terms of dependencies, there might be logical coupling we were not even aware of. And this gives you some further ideas of how to refine your modules. Sometimes it might be okay, but here you see quite a thick line. You see that shared seems to be custom tailored for ticketing. We have here 5 connections. That means 5 times they have been changed together. Might be okayish if you have 50 times in the last 1,000 commits or in the last 12 months, you can filter this here, then perhaps you should think about it. And one more time, it's just an indicator which points you to some things you should discuss, you should think about. What do we have else? Well, you remember we talked about Conway's law in the beginning, where we talked about that ideally your team structure should align with your architecture or vice versa. Your architecture should align with your team structure, which is the case here. Everything has been done by Team B. Who is Team B? Yeah, you know, someone needs to do the job. But this is not a good example. It's just an example repository I wrote. So let's restart this in demo mode. When doing this in demo mode, I get some additional people randomly squeezed in here to my statistics. And now we see where there is a team A, the purple one, there is a team B, the green one. And it looks like team A is doing most of the work here. So this is not an ideal alignment between your architecture and your teams. And one more time, this just points into one direction. This is not saying you are a bad person. It is just pointing into one direction. It tells you, let's discuss about it. Perhaps we can improve something here because Conway's law is a thing. By the way, as a side product of this, you also see your track factor if you drill down from the team level to the user level. Here, the red one is John Doe, and it looks like John Doe has implemented a lot of stuff here. So if John Doe leaves the company, you really have an issue. You have a track factor of almost 1 here and there and over there. Here, it's a bit better indicating. Here, Jane Doe took over. Okay, so team alignment, Conway's law. Change coupling, hidden coupling, you might not be aware of. And there is a last thing, which is called hotspots. A hotspot is an area of your source code that was changed often in a short time. Here in the last 1,000 commits, or perhaps in the last 6 months, it depends on you. It was changed quite often, and it is complex. So the more often it was changed and the more complex it is, the more it is a hotspot. And I really like this because this is not just a gut feeling. There is scientific evidence that if the same file is changing quite a lot, they call it code churn, is changing quite a lot in a short time period, then there are more issues in there. The probability of finding issues there is higher. There are several studies, and this can really be nicely automated, that point into this direction. And yeah, that's why we have this analysis here. This slider here tells you about how sensitive we should be. If we go to the left, we have more warnings and critical areas. If we go more to the right, we have less warnings and critical areas. A good starting point is 33%. That means the first third is green, the second third is yellow, the third third is red. And if we look in there, we find some files we should question. So why is this important for our architecture? Well, it's important for our architecture because if you have some files that change quite often, this might really tell you that you have an issue in this file with regards to your architecture. Perhaps you don't have a good modularization, and that's why every time you change one of those files, this file also needs to be updated. Perhaps you have duplications. In this case, you also have to change this together with that. Or perhaps you have what they call a God class, a huge file that is doing too much, including taking care of the nuclear power plant in the neighborhood. And then you also should think about splitting it up. So one more time, you get some indicators out of here. Okay, so I promised you an announcement. And I asked my colleague before, because funnily, we plan to announce it next week. But as I saw this awesome presentation about barrels, I really texted him on Slack and he gave me permission to announce it today. The thing is, Detective is currently no, not the detective, sheriff is currently also using barrel files because somehow we need to define our public and private API. Sheriff needs to know what others are allowed to access and what not. However, we were never happy with it because writing a barrel file, it's not complicated, but it's annoying. And there is some evidence, and we heard this today, that it is also bad for tree shaking and hence for the performance. So we had two good reasons why we wanted to get rid of barrels. And finally, we discussed this in this city about a year ago at Angie Bolland last year when we were sitting together, that we want to get rid of barrels. And yeah, with the next version of Sheriff, and it's already almost done, you can completely work without barrels. That means you don't need to type your exports time and again. You don't need to have those files. What you can do is you can define a special folder name like internal. And if you move something into a folder with this name, then you are not allowed to access it from the outside. And everything else will be public by default. So it's not annoying anymore. And you can change the rules. By default, it's called internal, but you can call it private, or there are ideas to define a club that you say if it starts with an underscore, then it's private. So it's really up to you. And I think it's good for our karma because, yeah, writing those files is not that fun. By the way, if you want to try this all out, then go to your source base and type in those two comments. Then Detective will start up analyzing your code base. You will get all those nice diagrams for your code base. And this is really fun because it gives you a completely new perspective to your source code. I always have the greatest fun when I'm analyzing source code I've written by myself, but because usually you don't have this perspective, but you say, yeah, it's true, I need to do something here and there. Sometimes you say, yeah, it's a hotspot, but I don't care, it's good enough. So try this out. By the way, if you want to learn more about all those things where we bring together architecture with the implementation you need at the end of the day, check out this free ebook. We meanwhile have 20 chapters. And we also cover, this fits to Matteo's talk, the Signal store in meanwhile 4 chapters. And yeah, it's free here in the 6th edition. So check it out. And a last point of information, we have this modern architecture workshop. We deal with maintainable and modern Angular there. We talk about Sheriff and NX, but also about Micro Frontends and module federation. So in general, we show you several flavors of how to implement an application that can evolve over time, that can grow over time, so that you can modify something here without breaking something there. We also cover, and this is one of the newest parts in there, signals and the signal store. And yeah, we have it in German and in English. It's fully online and interactive. The English version, by the way, is at the end of this month. So for the English version, you need to hurry a bit. Okay, cool. So let me conclude. What did we see today? We saw that decoupled verticals are a must if you want to have a huge application that can evolve over time. Somehow you need to put it into parts. We have seen that business domains are a good indicator for such a vertical. Not the only one. Team topologies give us further ones, like location on the globe of the development team and so on. But they also say, if possible, go with business domains. You should mirror your team structure. You should have an alignment between your team structure and your architecture, you know, Conway's law. You should think about cognitive load, because we want to have stream-aligned teams that can concentrate on one task. And you should work so that you have a flow and that you can provide business value quite easily. Remove all the showstoppers. And of course, there is a last thing, as always in my presentations. Please remember, good fences make Good. Neighbors. So that's it. Thanks for having me. I have already uploaded. Thank you. Thank you. That's very nice. I have already uploaded my material to my blog. You find it here. And follow me on X or on LinkedIn to stay in contact. Thank you.
Thank you, Manfred, for insightful presentation and for a great announcement. And now let's get to the QA session. You already know the rules, so you can raise your hands. Okay, we already have some.
Hello.
Hi.
I have a question. I was working with NX for quite a long time. I really liked it.
Mm-hmm.
But like 2 years ago, we had to switch to Micro Frontends due to the issue that we do something here and break something there, right? So is there any recommendation from you if I like NX and I want to avoid such an issue? Like, for example, we want to modify this shared UI library or something like that. And it accidentally breaks something everywhere. We cannot cover it with tests because like it's impossible to cover everything. Like a drop-down can become bigger and something is hidden outside of the screen and that's it. So how to avoid such things? Like maybe some helpful tricks. Like in our case, we can just roll back or update something more like granularly. But what to do here?
Yeah, that's an excellent question. And this is really what we focus on. We have a lot of customers with these huge applications where several teams are involved and so on. And first of all, it's about finding the verticals, of course. I assume you have found them. And then the big question is how to implement those verticals. And if it is a larger application, you mainly have two big possibilities with some sub-options. But the big possibilities are going with a monorepository or going with micro frontends in different repositories. There is an in-between solution where you have micro frontends in a monorepo, which gives you some advantages from here and there without getting disadvantages from here and there. But in general, regardless of which solution you choose for, you have some disadvantages. If you go with a monorepository, then somehow you need to make sure that your breaking changes are isolated. Having a public and private API can help here, but in this case, as you say, you need to make sure that at least the public API is backwards compatible. So making sure this is always the case can be difficult. Of course, something like code reviews can help, or something like automated tests can help, but there is no 100% solution. Also, if you go with a monorepository, you have a huge advantage. That is, you only have one version, or you can enforce one version, which makes things a bit easier. On the other side, enforcing one version and making all the people to upgrade simultaneously demands a process. It demands that people are coordinating with each other. And this is where micro frontends come in with several repositories where you have all the freedom. You can do what you want. You can update your repository when you feel it's the right time. However, it's more complicated now because you have several real applications. You need to build them, to publish them, and to integrate them because your user wants to have the impression of one application. Also, you can end up with having several versions at runtime. Angular in this and that version, you can deal with that, but that's not possible by default. You need to wrap your application somehow, for instance, in web components. And then you have increased bundle sizes. You can also deal with that. So there are also solutions for all those issues. But what I want to say, if you have micro frontends, the complexity is increasing. Not necessarily the complexity of the application itself, but the complexity for integrating everything. And this shows at the end of the day, you need to do an evaluation. You need to find out, I don't say what's best for you, I say what hurts the less. Because you will have some pains every time. And for this reason, some people decide for micro frontends, and some people decide for just about Monorepos. Some people decide for something in between. Perhaps one last thought here. NX is really cool, and no one prevents you from using several NX repositories if you really want to have this huge flexibility of having several repos. Very welcome.
Thanks. So I have two questions. The first one is a simple one. Are these tools like Sheriff and Detective available without NX?
Yeah. Yeah, so this is the idea. Sheriff and Detective work with and without NX. We really like NX, and we even use NX for implementing Sheriff and Detective. However, we also see that sometimes it's too much. Not everyone has it, not everyone can adopt it. And with those tools, we cover both worlds.
Cool. Thanks. Yeah, and the second question is, like you showed these verticals, yes, but what in real life we have a lot of cases when business evolves, yes, and some things becoming shared between these verticals, yes, and the biggest pain in such case when you have like 10,000 lines of code for one feature, and then someone else from another vertical comes to, okay, we also need this one, but change, I don't know, some drop downs, yes, and this becoming more and more a problem with Kotlin, yes. How to deal with it?
Yeah, that's a good point, because it really shows that in this case, we are not talking about perfect options. We are always talking about a trade-off. And especially when you're talking about sharing stuff. On the one side, we want to share stuff because we want to be dry. We don't to repeat ourselves because of code duplication and so on. And on the other side, we want to have autonomous teams that are not dependent on other teams, that can work in an autarkic way. And the truth is, we cannot fully have both. So we need to find a good position somewhere in the middle that suits our needs, that is minimizing the pains, because we always have pains. So what I would recommend is to discuss those cases in the team. Perhaps there is an architecture team, or perhaps you can do this with your colleagues that are also affected by it. Usually, I, in general, think that architecture should be in a team, and the architect is the moderator, but it's about everyone bringing in their observations. And then you can decide, well, this time we share it because it's less pain and it's such a complex component. And this time we don't share it because perhaps it just looks like the same now, but perhaps it will evolve into completely different directions over the next month. And then we would end up with a component having an if in every second line of the template, which is also everything but maintainable. So if you say it's a different thing, it just looks the same now, but we mean different things with it. It is the same vocabulary in a different meaning, then perhaps separated. Very welcome. Oh yeah.
Hello.
Hi.
Thanks for the presentation. My question is, I have experience in the backend mostly with domain-driven design and modular monolith applications. And in general, the communication in the backend mostly between two modules. It happens through different ways, but the experience that I mostly have is with a pattern called publish and subscribe. And for example, one of the most famous examples are order, like there is an order module and inventory module. When an order is placed, inventory needs to change.
Yeah.
You need to change something in the inventory. I don't know if the front end, this kind in real life, if for example, this kind of example can happen. But if we have a situation that we need to communicate between those two modules, and as far as I understand, the verticals kind of correspond to module, yeah?
Mm.
What are the patterns that we use for communication between two modules?
Yeah, good point. So, as you say, in the backend, something like publish, subscribe, messaging is a good thing. So let's assume the flight is cancelled here, then we also need to cancel the respective boarding. This can be done via messaging in the backend. And very likely this is a case we don't even need to address in the front end, because usually I don't have both windows opened. If I need to address it, then I also need some eventing like WebSockets or something like this. But more usually in the front end are situations where we need to access code from the other side, because we have some functionality in here we also need in the feature there. And then we have several possibilities. One possibility is to move this one into the shared area, the shared kernel, as you would call it in domain-driven design. By saying this, the shared kernel in domain-driven design is about domain-specific things. Here we also talk about sharing technical things. Domain-driven design does not say a thing about technical things, but nevertheless, the shared area would be a good place. Or perhaps you have several shared areas. It does not have to be this one shared area. Another possibility would be to allow this domain access to a very thin part of another domain. This is what you call the open host service in traditional domain-driven design. And here it would just be another barrel file or another sheriff rule that gives us very specific access to a specific part here. Not everything, only a specific part. And another thing, and this really fits nicely to stores and also the Signal store, but also Redux, is using eventing in the front end. I can also trigger an event and saying this, the next version of the Signal store very likely also gets an eventing layer. I think we've discussed today or yesterday with Marco from the NShareX team on X about this. So eventing is still a thing also in the backend, in the front end.
So you mean that the what is called integration events in the backend for communicating between two modules can be achieved by redirects?
That's possible. So I would call it a domain event, something like, hey, I've booked a flight or I delayed a flight. I just shoot it out, and if other parts on my page are interested into this very information, they can act accordingly. So it can be done with Redux. It can also be done with a service and behavior subjects, or just subjects.
So I have a question. I really like the detective library, but I believe it does not work without the sheriff library. How hard would it be to migrate from, for example, Ethnic plugin boundaries plugin or the NX ecosystem that allows us to make the boundaries between the libraries to the sheriff? Is it a hard process?
It's not a hard process, because for sheriff, everything is just a folder. That means, first of all, you can just configure sheriff so that it is using the existing folders as modules. And then as you go, you can refine your configuration so that sheriff is also recognizing subfolders and subfolders as further modules with further access restrictions. So the good thing about sheriff is you can really introduce it incrementally and enforce the rules incrementally.
Okay, I really like that. Thank you.
Cool.
For sharing insights and good stuff. And I saw good presentation screen that you divide teams or some features by risks. How do you do this?
Teams by releases?
By risks. not by releases. Previous I don't know, presentation screen.
Yeah, it was.
Next one, no.
Here.
Yeah. You said that we can divide the features by risks.
Yeah.
And this is quite interesting question.
Oh, yeah. So the main fracture plane is still the business domain, but in some cases you might do something like this. And dividing by risk is something we might see in applications with a danger zone. So perhaps you have some features that are that dangerous, that are that critical, that you want to have an own team on those features. Perhaps those people are even specialists for risks with regards to business, perhaps laws or other risks, or specialists with regards to computer security, because it's that sensitive. It's nothing you have in a lot of applications, but if you think about banking or insurances, then you might have a highly risky application or sub area, and you want to have perhaps a complicated subsystem team responsible for it that is really hardening this part, making sure no one breaks in there. Sensitive medical information or your wages, stuff like this. Very welcome. But yeah, in some of those cases, I also had to think a lot, and I had to read those chapters several times, because while this guy is here most obvious, some of them are not that obvious and not that often used.
Hello, I have a question about that graph and those layers. What actually is like data layer, and is it more like some business logic layer or infrastructure layer, or what actually is it? And why UI, like those dumb components, can have access to it?
Yeah, interesting question, good question. So what's the data layer and why has UI access to it? Well, here we have the recommendation by the NX team, and I really like to use it as a starter point, because they have a nice in-between between too much and too little. You know, with each and every layer, you are adding some cognitive load and complexity. But you are right, quite often the data layer consists of several aspects. It consists of your model. How is a flight structured? How is a ticket structured? How is a passenger structured? And it consists of services operating on those models, like loading stuff from the backend or saving it to the backend. And sometimes there might be a bit of logic. I mean, the most logic is in the backend, but sometimes we have this kind of logic we also want to have in the front end, something like we cannot have this option and that option together. If you charge you on a monthly basis, we cannot show you the discount possibilities. And we cannot charge you on a monthly, weekly, and yearly basis at the same time. So perhaps a bit of logic is in there, or also perhaps we are delegating this logic to the server. But then also here the logic has the entry point here, and the entry point delegates to the server side. And as you see here, regarding on your situation, you might end up with several aspects in the data layer. And for this reason, some people want to split it up into, let's call it a domain thing that contains domain logic, into a data access thing, and into a model thing, data models. And you're right, if you have an own model library or module, then UI only needs to have access there, but not to data. Because your UI component perhaps needs to know how a flight tickets look alike, but it does not need to know how to load and save the flight ticket. So if you subdivide it, then you don't need to have fully access to everything in this layer from within UI, and you can decide to go with even more layers, sometimes even with more dimensions. Here we have 2 dimensions because it nicely fits on a 2-dimensional you know, PowerPoint slide, but I have also seen products with more dimensions. Then those dimensions are more categories so that they fit your brain.
So, for example, like hexagonal architecture inside such a vertical is a solution for that, or not really?
It can be. So it can be. I have even thought if I should talk about it. I have thought it through, but usually I don't talk about it because I have the impression often it's too much. Because what is hexagonal architectures about? The main point of it is about completely separating business logic from infrastructure logic. And if you have a lot of business logic in your client, then this makes sense. But if you mainly delegate via the infrastructure, via HTTP to the server, then hexagonal architectures might be an overkill. But if you have a need for it, if you have a lot of logic, you want to decouple, yeah, then go with it. There are even some reports out there of people doing this, but I think it's rather something you don't need that often because the majority, and I think not the majority, but the vast majority of the business logic is on the server side. But it's a good point, and it's something we also thought through.
Okay, we have also some questions in the chat. So first will be from No Frost. I guess that's a reference to your fridge anecdote. But anyway, the question is, if we have a larger vertical than our team, are there some good practices on whether we should increase our team size or change the scope of the vertical?
Well, I have the impression quite often it's both, because you cannot increase the team size ever and ever again. I think if you have more than 7, 8 people, then you're reaching this limit. You should not have more. Saying this, I have also seen teams with 12 people that worked nicely together, but as a rule of thumb, 7 plus minus is a good amount of people in a team. So you cannot do this game forever. And when in doubt, perhaps splitting the team is not that bad. I have also seen situations where they refactored out a complicated subsystem of a vertical. And in this case, they had specialist people working on this. So we can actually do both. And it depends a bit on you and the forces in your companies, how to align your source code with your team structure.
Okay, thank you. And one final question from Mateusz. How do backend domains translate to frontend domains?
That's also a perfect question. So I already see we are getting a lot of good questions here, and trust me, this is not the case every time, but this is a perfect question. They align sometimes, and sometimes they are completely different in the backend, because a domain can, or perhaps because we can have a completely different view on the domains from a backend perspective compared to a front-end perspective. The front-end perspective is mainly about the user flow, the user journey. And this does not necessarily fit with what you have in your business and in the brains of your business experts. Let me give you one example from my practice. It's one more time about payroll accountancy, which is quite complicated. You know, a lot of laws, and they are changing all the times. However, we need to keep the code from last year, because if we correct your wages from the last year, we need to align the laws from last year, not from this year. So it's really complicated. And because of this, you might end up with a lot of domains in the backend. From the front-end perspective, it's in most cases quite easy. In most cases, you define who gets which amount of money at the end of which month. And most of the times you even say, we repeat this for all the further months until he quits or she quits, or we throw them out, something like this. So most of the times the user journey is quite simple, but behind the covers, a lot of stuff is going on. And this is a good example where the domains don't align. In these cases, I would think about introducing a backend for frontend that is orchestrating several domains for a frontend domain. On the other side, if you are lucky, you have a perfect alignment. If you think about an ERP system with, let's say, financial accounting and with asset accounting and cost calculation, there you have areas that can be nicely separated. Even more, most financial accountants in bigger companies don't deal a lot with cost calculation because you have different people for those tasks. And so usually they only see one vertical in the majority of cases. And yeah, in this case, you can align perfectly. And as so often in this ugly world, there are a lot of cases between those two extremities.
Okay, thank you. So we've reached the end of our Q&A session. Thank you again, Manfred, for being today with us.
Thank you.